These are your 7-3B notes, solving exponential equations. In this section, we're going to learn how to solve exponential equations using the power property of equality. And so first, before we can solve an exponential equation, we should probably understand what that actually means. An exponential equation is an equation where the exponent is the unknown value. We have not had that yet. All the equations we've solved, the variable has been multiplied by numbers, added and subtracted from numbers, but we've never seen the variable up as the exponent. So when the unknown value is the exponent, it's considered an exponential equation. The rule we're going to use today is, I like to think of it as a common sense rule. I call it the this equals that rule. It's one of those concepts that it's kind of common sense, but it is a rule and it's a property that we just accept mathematically. The property of equality basically says if you have some number raised to an exponent and it equals that same base, that same number raised to another exponent, then the exponents must be equal. Then x must equal y. So I know with variables it's a little difficult and with those unknown values. So let's try it with numbers. If I have 5 raised to some unknown value, but it's equal to 5 to the third power, then I would say that x is equal to 3. Okay, so basically, this is that whole if this equals that part. If 5 is equal to 5, then x has to be equal to 3. So if the bases are equal, then the exponents must be equal. Okay, in the second example here, I have bases are equal. Okay, I have -2 to some power is equal to -2 to the fourth power. So if this equals this, then that equals that. So we have a little equation here. X plus 1 equals 4. If you subtract 1 from both sides, x must equal 3. And so what you're looking for is if you can get a common base and you can set the bases equal to each other, then you're allowed to set the exponents equal to each other. So we just sort of ignore the base. Notice in the second example, I just excluded the -2's. I know the -2's equal each other. I'm concerned about their exponents. So that's the logic that we're going to use today. So here's your step-by-step of how to solve these equations. First thing you're going to do is you're going to rewrite the equations so that you have common bases. You're going to use a calculator to figure that out, okay? So you're probably going to want the calculator for this part just to kind of figure out how can I rewrite my base. That's the most important part. Once you get a base equal to another base, you can ignore the bases and set the exponents equal to each other. So exponent equals exponent, and then solve, just like I did in the example. So let's go ahead and try it. All right, so number 1, we have 9 to some power is equal to 729. So I see that huge 729, and I'm wondering if that's a power of 9. So on my calculator, I'm going to type 9 times 9, and I get 81. I'm going to times it by another 9, and I get 729. Okay, so what I just did on my calculator is I saw that 9 times 9 times 9 gives me 729. I wouldn't expect you to know that right away. And so if you notice, that's 3 times itself. I multiplied 9 3 times itself, so 9 cubed is equal to 729. So rather than writing 729, I'm going to rewrite 729 as 9 cubed. And I'm going to set it equal to the other side. So now I have 9 to some power is equal to 9 to the third power. I have this equal to this. The 9's match. Therefore, that equals that. X is equal to 3. No real work necessary there other than rewriting 729 as a power of 9. Okay, so one of the clues that you can use here, notice I had 9 and I had 729. take the bigger number and try to write it as a power of the smaller number, okay? So looking at number 2, I'm hoping that that just makes sense to you, and hopefully you know this, you don't need a calculator. 25 is 5 squared. And so I'm going to rewrite 25 as 5 squared. But since 25 was being raised to the x minus 1 power, now 5 squared is being raised to the x minus 1 power. On the other side of the equation, 5 raised to the first. So if there's no exponent there, remember that that's a 1. You can put a placeholder 1 there. So I'm almost there. I have the 5s, but I need to clean up this exponent. So I have a power of 2 raised to a power of x minus 1. I have a power to a power. When you raise a power to a power, you multiply. So I'm just going to go off to the side of the page and clean that up. So I have 2 times x minus 1. I need to know what that equals. So that's, if I distribute my 2 through, I get 2x minus 2. So I'm going to rewrite the left-hand side of this equation as 5 to the 2x minus 2 power is equal to 5 to the first power. If this equals this, which they do, then that equals that. So the next part, I'm almost done. I can take those two exponents, 2x minus 2, set them equal to each other. 2x minus 2 equals 1, and solve for x. That means I'm going to add 2 to both sides. Okay, it cancels out. 2x is equal to 3. Divide by 2 to get rid of the 2. X is equal to 3 halves or 1.5. You can just leave it as 3 halves. So whenever we solve, our answers should be numbers. Okay, you're giving me the value of x that makes this statement true. So number 2 was a little bit more work involved. Okay, number 3. Number 3, I know 16 and 8 have something in common, but if I do powers of 8, 8 times 8 is 64. It's too big. And 16, I can't write as a power of 8 either. But what they do have in common is I believe they both are 4s, right? I look at that and I see a 4. But when I try to write 8 as a power of 4, I know it's 4 times 2, but 4 squared is 16. I can't write 8 as a power of 4. So then I have to think through and come up with another number that they have in common. So I'm thinking out loud here because this is what you need to do. You got to come up with the relationship between these two numbers. So I could not use 16 and 8. I couldn't use the numbers directly like I could in the last examples. I tried 4 because it looks like 4 would be a right fit. 4 didn't work, but I know 2. So let's go ahead and use our calculator and see if we can come up with 16 using 2. So if you take 2 and multiply it by itself 4 times, you get 16. So I'm going to rewrite 16 as 2 to the 4th. Now notice, I did that in the background. I used my calculator. Before I even begin the problem, I had to plan it out. So 16 becomes 2 to the 4th, and that's raised to the 2x minus 1 power. And 8 is 2 times 2 times 2, or 2 to the 3rd. So this becomes 2 to the 3rd power raised to the x power. We're just replacing the numerical part. So since 8 was being raised to the x power, 2 to the 3rd is just another way of writing 8. So it is also being raised to the x power. You have power to a power. We need to multiply these. Now I can just do that multiplication as part of my work. So I don't have to go off to the side of my paper. Since I have common bases, 2 is equal to 2, I can go ahead and the next step is to write my equations. That 4 times 2x minus 1, that's the power to a power, that's the exponent on the left-hand side, is equal to 3 times x. That's the exponent on the right-hand side. I need to distribute the 4. So 4 times 2x is 8x. 4 times negative 1 is negative 4. And this equals 3x. Now I'm going to bring the 8x over. So I'm going to subtract 8x because I want to get the x's to the one side. The 8x's cancel. I bring down the negative 4, don't forget the negative, is equal to negative 5x. Divide both sides by negative 5. And x will equal a positive 4/5. Just leave it as a 4/5. X is equal to 4/5. If I wanted to check my answer, anytime we solve, we can check our answer. You always go back up to the original problem. So if I go to check this answer, I should plug 4/5 in for x in the original equation. And it should work. 16 times 4/5 times 2 minus 1 should be equal to 8 to the 4/5 power. Now I know that's a kind of a weird answer, but if you use your calculator, it should give you an ugly decimal either way. Okay, and it should give you the same exact ugly decimal. So if you take 2 and times it by 4/5, subtract 1 from it, you end up getting 0.6. 16 raised to the 0.6 power is 5.27. And 8 raised to the 4/5 power is 5.27 as well. So because they both give you the same ugly decimal, it works. Let's look at number 4, a little tricky here. Okay, it's just making you think. This is the hardest part, is the stuff before you even start the problem on paper. So what I noticed for number 4 here is that I see a 4 and I see a 2. So I want to rewrite them as each other, so I know I can write 4 in terms of 2. So I'm going to change this 1/4 into 1 over 2 squared is equal to 2 over x plus 1. And I forgot to raise that to the second power. So I just wrote 1/4 as 1 over 2 squared, because 2 squared is 4. I'm getting closer to having matching bases, but this 2 on the left-hand side is in the denominator, and the 2 on the right-hand side is in the numerator. So I can use the idea of negative exponents if I want to flip this and bring this 2 up top. That just means I have to raise it to the negative 2 power. So by bringing it up, 2 squared goes up top, 1 goes down below. It changes my second power to a negative second power. It's still equivalent as long as I changed one thing, so I have to change something else to balance it out. And that is equal to 2 to the x plus 1 power. Let me clean that up. When I raise a power to a power, really I don't need this 1 here. It's really just a whole number. Okay, anytime a fraction is or a number is over 1, it's just a whole number. So a power to a power, I multiply. And so what I have now is 2 to the negative 4th power is equal to 2 to the x plus 1 power. And now I finally have matching bases. So if this 2 is equal to this 2, then that negative 4 is equal to that x plus 1. So that's where my equation comes into play. Negative 4 is equal to x plus 1. Subtract 1 from both sides. X is equal to negative 5. And there you have it. All right, so I know they're a little tricky. They require more thinking. The mathematical part isn't too difficult. It's more of the thinking part. So for your summary, according to the power property of equality, if 3 to the 4th is equal to 3 to the x, then what is the value of x? And the practice problem is, here it is, solve this one. Rewrite 81 as a power of 3 and solve for x. Good luck.